So I want to start by saying thank you everyone for joining. My name is Cody Armstrong, and today we're talking about advanced part modeling in Onshape. And when I say advanced part modeling, I'm really referring to features and things that we didn't really get to discuss in the Onshape Essentials webinar. So really anything outside the typical sketching and extrude, things like Revolve, Sweep, Loft, compare, derived features, a number of different little things that again we just don't have time to cover in the essentials. So advanced part modeling, as I always say with these webinars, we really encourage you to ask any questions that you'd like. There's a questions dialog and you go to webinar control panel. Feel free to type in anything. I'll do my best to stop and address the questions from time to time. So again, thank you for joining. This is the advanced part modeling. Let's jump into it. Now, before I get into the topic of the day, for those new users to Onshape, there are a few things I'd like to point out about Onshape in general. And one of the first is our mission statement. That is getting everyone working together with CAD on any device, anywhere. So if you haven't used Onshape on a mobile device, it's really something that we haven't seen before in a 3D CAD application. The ability to not only view but build 3D CAD models on a mobile device, and this includes iOS and Android. And you can create real parts, sketches, features, assemblies, all from your phone or from your tablet. So it really is a CAD creation tool, not just a viewer. But again, our goal with Onshape, and not just specific to mobile, but in general, is everyone working together with CAD on any device, anywhere. Now, what are the other key things to keep in mind with Onshape? One of the first is we do consider ourselves professional 3D CAD, and when you think of professional 3D CAD, it's really three pieces: parts, assemblies, and of course drawings. And we do have all three major pieces that make up a professional 3D CAD system. Some things that really set Onshape apart is one is its release cycle. You're going to see Onshape update very frequently. So with Onshape, you don't have to install, you don't have to download anything, and frequent updates happen in the background. And the neat thing is, roughly every 3 weeks, you're going to see new functionality being added, and you don't have to do any work. Right? There's no installs, there's no updates. You just simply log in, and new features will be there. So you're going to see Onshape evolve very quickly. But also some key things I'd like to point out about it is with Onshape, you have built-in version control. So you don't have to have a separate data management system to manage files. That concept is gone in Onshape. And we have version control built into the core. And the neat thing about this is you have a complete history in Onshape of every step in the document taken since the very beginning. So we can restore back to any moment, and we can also capture milestones in the design with version control. So you really have an infinite undo with everything you've done in Onshape. Now, some other things I like to point out, we also have the ability to import and export common CAD formats. So if you have a library of CAD data coming from another CAD system, chances are we can import and export formats that work with those systems. So just keep in mind, if you have a library of CAD models, or even DXF and DWGs, for example, can be imported and edited, manipulated inside of Onshape. So you can both import and export a lot of common CAD formats that are out there. This also means that Onshape works well alongside an existing CAD application. Maybe use Onshape to share, or maybe use Onshape just as a tool for collaborating with a vendor, for example. But because we can import and export, it means we work well alongside other CAD systems. The last thing I want to mention is with Onshape, we've introduced entirely new methods of collaboration. So if you haven't shared your document yet, I definitely recommend it. In the top right, you hit the share icon, you enter their email address, you define their permissions, and you hit share. And that's all there is to it. They don't have to install anything, they don't have to download anything. They click a link, and they're looking at the same model as you. Even if they don't have an Onshape account, you can share with them via a link, and they can view the model. So with Onshape, we've introduced entirely new methods of collaboration, making it very easy to share your design. By default, of course, every document you create is private, but if you decide to share with someone, it's very easy to do. And you can also work together in real time. So instead of being a file-based system where one person can edit an assembly at a time, you can have 2 or 3 people working together on the same assembly at the same time. So entirely new methods of collaboration, including things like real-time simultaneous editing, real-time comment capabilities integrated into the document, including the ability to tag features, and also follow mode and the ability to see each other's screen in real time. So all kinds of very cool stuff built around collaboration, built around sharing your documents. So if you haven't already, I definitely recommend checking out some of those tools. So these are just some things that I want to mention about Onshape in general. What are we going to talk about today? Well, as I mentioned before, I refer to it as advanced topics, but really it's anything that we don't cover in our Getting Started Essentials webinar. The big things are sweep, revolve, and loft, right? We've covered the extrude command in detail in the Essentials webinar. I'd like to get into sweep, revolve, and of course, loft. Real quickly, question. With other online CAD programs I've seen, I had to log in on a regular basis to keep the license active. If I set up an Onshape account, do I have to do the same thing? No. There's no, once you create an account, it's there to stay. You don't have to reactivate the account or license. So if you're using a free account, you could go away from Onshape for an extended period, come back, and there's no activation of a license that needs to take place. Okay, so as I mentioned before, this is really about sweep, revolve, and loft. That's where I want to spend the bulk of the time. Those are the four commands, or three commands, excuse me. Fourth being extrude, that kind of make up everything that we do, or a large majority of what we do with our CAD models. Then I want to get into some other specific commands, things like hole feature and shell. These are two very powerful commands. Derived feature, another very good example, where I can import parts from one part to another. And things like versions and compare, the compare capabilities. Quick question, how can we link together parameters in a model or between models? What I would do, just as a tip, I'm not going to go into too great a detail, I will show an example of this later, is take a look at the derived feature, which I'm going to cover in just a bit. It allows you to insert models from other tabs into the current tab and link them. So this is the goal. Again, sweep, revolve, and loft is the big ones, but also a few other miscellaneous features as well. So let's dig in. Now I want to start real simple with revolve and sweep, and I want to do them in that order. So we're going to start with the revolve command. And the thing to keep in mind with the revolve command is it's really about round parts. You're creating a round part every time you create a revolve. And the way to think of a revolve is essentially like sketching a slice section of that round part and then rotating that sketch around to create a full 3D round solid. So that's the idea behind a revolve. Now, to get started in this case, it doesn't really matter which sketch plane I start on. In this case, we'll just start on the front. But a tip that I have, and this is something I like to point out in every webinar, is the right-click menu. And this is in general just a big tip in Onshape. I need to rotate normal to the sketch plane to start this. So I'll right-click, view normal to sketch plane. Okay, so just a tip in general about Onshape. The right-click menu has a lot of very useful options. Now, in my case, I want to start sketching my revolve profile, the sketch that I want to rotate to create a revolve. Now, in general, and this is just a best practice, it's not something that's a rule, but in general, it makes sense to start with what you want to rotate the revolve about. Remember, we're rotating the sketch around. So what are we rotating about? And so oftentimes what I'll do in a revolve is start with a construction line. Right? So I'll select line, construction, and in this case, I'd like to rotate horizontally right through the origin. So I'm going to sketch a horizontal construction line through the origin. And the key thing here is this is just an easy reference for me to define what I'm rotating about when I do my revolve. So that's oftentimes the first step. Now, what I'd like to do is start sketching my revolve profile. I'm just going to use a series of basic lines to construct a very simple shape. Right, so just using a series of lines. Now, a few tips that I have regarding sketching in general. One of the first tips that I have is what we call waking up endpoints. And if I move my cursor down here, you'll see as I'm moving my cursor, I want this line to be the same distance as the line on the right. But it's not automatically giving me that inference. You'll see as I move the line, it's not attaching to that point or that reference. However, if I move my cursor over the point and then move it back, you'll see that inference now appears. So now I can attach the reference automatically. And so I don't have to go back and constrain this later. So just a tip when sketching, you can wake up any point. So also very useful here. I want a reference to that point on the right. It's not appearing. Move my cursor over it, come back, and now I have the inference. Right. So I've sketched a real simple Revolve profile. Now, in general, there are a few things that I want to point out about this sketch. One of the first is that it's not centered or dimensioned in any way. So if I grab a point or a line and I drag it, it's free to move anywhere. One of the first things that I want to do is I want to constrain this sketch over the origin. Right? I want it centered over the origin. And so to do this, I'm going to create another construction line. And this is just not specific to Revolves, but it is very common in Revolve command to draw a construction line vertically, like I did here, and then attach my geometry to that vertical reference. And this will allow me to center the Revolve profile over the origin. Now to do this, we'll create what's called a symmetric constraint. So I'll select point, line, point, and choose symmetric. Now the key thing here is now this line is centered around that construction line. Right? So it will remain centered no matter what dimension I change this to. So I need to do this in a few places. Again, point, construction line, point, symmetric. And this will give me that centered behavior that I'd expect. So as I drag this now, it behaves with symmetry. So now let's add a few dimensions. We'll add a few simple width dimensions here. Now, what I'd like to start doing is, of course, defining the diameter. Remember, this is going to be a round part, so we're going to take this sketch and rotate it to create a round part. However, if I select this line, for example, and this construction line, by default, I get this value. Right? I get what is, looks like 829. So in this case, if you think about what we're doing here, we're taking this profile and rotating it. That's actually a radius value, or it's half the value of what I'd actually like to drive this with. So a tip when you're defining Revolve sketches like this, if you dimension to a construction line like I've done, and then you move your cursor past the line, it will automatically double the dimension and add a diameter value. So this is particularly useful in Revolve sketches like this when you're trying to define by diameter instead of radius, right? So now I can go through and define the diameter of all these profiles instead of the separate radius values and having to do the math of cutting everything in half. So the neat thing about this too is, of course, it's a more accurate reflection of your design intent. So again, just another tip about sketching in general. That if you construct your dimension about a construction line like this, you can double the value. Very useful in Revolve sketches like this. So we've got our sketch. It's centered. It's fully defined. Every dimension is there. We're ready to revolve. So I select the Revolve command from the toolbar. Now, the sketch in my case is automatically selected, but the revolve axis is not. And that's a very important thing. As I mentioned very early on, one of the key things with revolve is defining what do you want to rotate about. What is the axis that you want to rotate about? And if you remember, the very first line that I sketched was that axis, with that horizontal construction line that I sketched. So now I'll select that construction line, and that becomes my revolve axis. Okay. And now you can see it's taking that simple 2D sketch that we created, rotating it 360 degrees to create a round part. Right? I can hit the green check OK, and there is our revolve. Now, a few things about the revolve command. I'm going to go ahead and right-click in the feature list and edit the revolve. A few things I want to point out, and they're just commonly asked questions. You don't have to do a full 360 revolve. You can do one direction, and I can specify 45 degrees, for example. I can do symmetric, so I can define I want a symmetric revolve, 90 degrees. It'll create a 90-degree slice. So you have some options. The last one I want to point out is 2 directions, which allows you to specify a certain degree, a certain amount in one direction and a certain amount in another direction. Okay. So just some things I want to point out about the Revolve. By default, of course, it'll be set to full, but you can specify other types. So that is the Revolve command. Again, just some tips in general. You always want to know where your rotation axis is, where your revolve axis is in your sketch, and you can construct it. It can be one of the lines associated with the geometry. That's fine too. But in general, you want to know what am I rotating this about? So real quickly, that is the revolve command. I'd like to jump into an example of sweep. Now, the key thing to keep in mind with a sweep is there's really 2 pieces to every sweep. There's a profile and a path. And it's very important. You must have both pieces to create a sweep. And I think a great example of a sweep is a U-bolt. Everybody kind of knows what a U-bolt is. I'd like to walk you through building a simple U-bolt. Now, to do this, we're going to create 2 sketches. So in my sweep, I'm going to have 2 sketches, and I want to start with the path. So for this sweep, I want to start with the path, and I'm going to start on the front plane. So we'll select front plane, sketch, and again, I'll use right-click, view normal to sketch plane. Now, the key thing with a sweep is, again, you're taking a profile and sweeping it along a path. So the path reflects, overall what the shape will be. In the case of a U-bolt, it's the U shape. So let's start with a simple line. I'll select the origin here. We'll draw a vertical line. I'll select a tangent arc. We'll make a tangent arc from that line. And then finally, we'll finish with one last line back to a horizontal reference to the origin. So basic U shape for the path. Now, some things to keep in mind about this sketch. I created a tangent arc, which means this arc is tangent with this line. However, this line is not tangent with this arc. So just a tip, if you show constraints, you'll see that there is no tangency between the line and the arc here. Very easy to add though. Left-click the arc, left-click the line, and select tangent. Okay. So now that we've added the constraints, the last step, of course, is to add dimensions. So we'll dimension the width as 1.5 and the height from the center point as 1.5. So now we have a fully defined sketch, and this sketch is the path that we want our sweep to follow. And we're done with it. So I'm going to hit the green check. And we're ready to create our second sketch. As I mentioned before, in this case, a sweep requires 2 pieces, a profile and a path. So we're going to create 2 sketches. Now, a frequently asked question, how do I know where to put the profile with respect to the path? And in general, we'd recommend creating a plane or using a plane at the end of your path. So if you look at my sketch, the end of the path is right here at the origin. That also happens to be the default top plane. So it just so happens I can use the top plane in this example. However, if you don't have a plane, let's say, for example, your top plane doesn't in there, and you need to insert a plane. If you select plane, there's an option for curve point, where you can select the line and its end point, and it will automatically insert a plane normal to the end point of the line, right? Normal to the end of that, right? So very useful for sweep profiles. So just a tip in general, you may need to insert a plane. Curve point can be very helpful in those situations when creating that plane. Okay, so again, you want in general to make sure that your sweep profile is at the end of your path. Now, in my case, that is the top plane. So I'll select the top plane, sketch, right-click, view normal to sketch plane. And I just want to sketch a simple circle. Add a diameter to the circle. We'll give it 0.375. And now what I'd like to do is attach my profile to the path. A very important step when you're creating a sweep. Your profile must be attached in some way to the path. Now, there are a few ways I can accomplish this. I could create a coincident constraint between the center point and the end point. But another very useful one is the pierce constraint. So in this example, I can select a line and the point and create what's referred to as a pierce constraint. And what this pierce constraint means is where this line intersects my sketch plane, that's where it will attach the center point of the circle. Okay. So again, the key thing to keep in mind with a sweep is you must attach the profile to the path in some way, whether it's coincident constraint, pierce constraint, it just depends on the scenario, but it must be attached, right? And so that's it. Now I have my profile, which is the circle, and I have my path, which is that U-shaped sketch from before. Now, in this example, let's do real quickly here a sweep. Real quickly, question. You created the plane using curve point. How is that different from point normal? Point normal will use the normal direction of the sketch point or vertex. Curve point will use the curve direction. So in that example, it wouldn't have made a difference because the line happens to be perpendicular to the plane. But in a more complex example, there would be a small difference, and it would be that the plane is normal to the end of the curve. I think that's the key difference. So forgive me if I'm not explaining that perfectly, but in this example, there wouldn't be much of a difference. In another example with more complex path, there may be. Okay, so I'd like to take the profile and sweep it along the path. And there are a few things I want to point out about this. First, of course, we select the sweep command from the toolbar. Now, there are two things to keep in mind. There are two boxes here, really, and you have your profile and your path. In my case, the profile is pretty simple. It's just the circle. Right? The path is what I define from the sketch. Now, a tip is you can select any piece of this sketch by left-clicking in the graphics. So if I wanted to sweep only along a certain part of the sketch, you can do that. So I can select these two pieces of geometry and it sweeps just to the end of them. I can select all three, and of course it gives me all three. But a tip, if you have many, many lines and arcs, is you can also select from the feature list. And this is very useful if you don't want to left-click a whole series of lines or arcs or window select. It's just very easy to select it from here. So just a tip, you can select from the feature list and we'll add all the geometry from that sketch. So very easy again, profile path, green check OK, and we have our sweep. Okay, and again, you can see that it's taking the circle and just sweeping it along that path that we created. So that is the sweep command. The key thing to keep in mind, it often requires two pieces, a profile and a path, and those two pieces need to be attached to each other with some kind of constraint, pierce constraint, coincident constraint. It really depends on your scenario you're sketching. So that is the revolve and sweep command. Now, a real quick frequently asked question, what about something like threads? What if I want to add threads to this U-bolt? And you can certainly do that. You can even go to the level of detail of actually doing a swept cut to cut the threads into the part. Oftentimes users find this isn't necessary, for the purpose of manufacturing, but if you really want the utmost detail, you can certainly do it. A tip is you can select the helix command to define the path for your threaded cut and select a cylindrical face as a reference. So I can select helix, select this cylindrical face, define it by pitch, and say, okay, it's a 12 pitch thread, so we'll say 1 divided by 12, an inch thread. Clockwise, counterclockwise, green check OK, and it adds a simple helix. Now, oftentimes this is enough just to show that there's a thread there, but if, again, you want to go to the extra degree of detail, you can sketch a small triangle and do a swept cut, having the triangle follow the helix, and that will actually give you a realistic looking thread. Again, oftentimes it's not necessary, Many users find that level of detail isn't absolutely needed, but if you want it, you can certainly do that. And again, it is another sweep where your profile is your triangle, your path is the helix. Okay, so it's another example of a sweep. Okay, so for time's sake, I'd like to move on. So that is revolve and sweep. The last major tool that I want to focus on here is the loft command. And if you think of the major tools that we have in Onshape, it's really extrude, revolve, sweep, and of course loft. Now, the key thing to keep in mind with a loft is it oftentimes requires a little bit more detail, a little bit more time than any of the other standard tools that we pointed out. So the main thing that I want to point out is if you can accomplish your part using something like an extrude, revolve, or sweep, or a loft, or excuse me, extrude, revolve, or a sweep, you're often better off. It'll often be faster. A loft is very useful when you're trying to create shapes that aren't easily created using one of those tools. However, it often means that it takes more time. Lofts in general take more time to set up and create. But if you're looking for a very specific shape that you can't easily create using one of those other tools, loft is kind of the go-to. So let me point out some key things about loft. One of the first things is what you're essentially doing is you're transitioning from one contour to another. So here's the grip of the squeegee, and if you look at it, it's essentially just a loft between this circle and this circle. The neat thing about this is with a loft, unlike something like a revolve, is I can add things like guides, and guides allow me to manipulate the shape via other sketches and create shapes that I wouldn't easily be able to create using something like the revolve that we looked at earlier. So here's an example where, again, just loft between a circle and a smaller circle. But the introduction of guides, these sketches where the splines exist, creates that shape that you'd expect to see in a grip. Okay, so that's a very simple example of a loft. And the key thing there is you're really just going from one circle to a smaller one. However, lofts can be a lot more complex. You can create transitions from a circle to a square to a rectangle, for example. So here I'd like to create the feature joining this handle with the actual squeegee itself. And there are a few things that I'd like to point out with it. One of the first, and it's one of the easiest mistakes to make as a new user with the loft command, is to use faces or references that don't have the same number of vertices. Let me show you an example. I want to loft between this face and the circular sketch, or excuse me, the rectangular sketch. Right? So I've selected the circular face. I've selected the rectangular sketch in my part. One thing to notice is the amount of twist that you see in the loft. Because the number of vertices don't match between the loft profiles, you have to split the number of parts up, all right, the number of vertices up. And so a tip, by default, if you just select a face like a circle and something like a rectangle, the odds of it mapping correctly, the points that you want, is slim. So what you can do is instead use a sketch. So let me show you what I mean. This is sketch 5. And just a tip is it's still a circle. It's just a sketched circle, but it's been split into 4 pieces. And that's the key difference because now it has 4 points, just like a rectangle. And the neat thing about this is now when you loft between this sketch and the rectangle, you'll get the correct orientation. The correct points will map to each other and give you a much smoother transition. So this is one of the first tips that I can give you with a loft. If you just select 2 faces, the odds of it coming out perfectly are slim if they're drastically different shapes. If I'm going from a square to a square, it might look just fine. But if I'm going from a circle to a rectangle, for example, you'll need to do something like this. So again, simple circle, you use the split command right here in the toolbar to split the circle into pieces. So now when you do a loft, instead of selecting the face as a reference, I can select that sketch, right? We can select it even from the feature list. And again, the key thing there is, and the big thing is, you will not get by default that same twist. So now you'll notice it's a much cleaner transition between the handle and the squeegee itself. And again, the idea behind it is it's just using the points that we split to as references for the loft. So that's one of the first things, again, using the split command, splitting up the sketches into the same number of vertices. Now, the other commonly asked question, can you loft between more than 2 profiles? And the answer is yes. You can loft between as many profiles as you'd like. So there isn't a limit. You can loft as many profiles as you'd like. The tip that I'd give you is when you're in the loft command, make sure to select them in order. You wouldn't want to jump around in order. You'd want to go from left to right in order, or from right to left, depending on how you select it. But again, the key thing there, you can have as many contours as you want. Just make sure to select them in order. Now, this is a real simple loft between a circle and a rectangle. But there are a lot more controls that you can do with a loft with really any other, compared to really any other command. And there are 2 things I want to point out here, guides and end conditions. Now, a tip is, in general, I would start with end conditions. They're very easy to use, and they don't require much effort. So I can choose something like end conditions and say, okay, I want this to be normal to the profile. And if you look closely, you'll see that it's transitioned so that it's normal to the profile for a little bit longer before it transitions to the rectangle. Another example is, just real quickly, let me take this back to none. You can see the difference. So very sharp transition from the handle. Change this back to normal to profile. You'll see it's extending that profile normal to the sketch plane for longer. So there's a really powerful capability. There are a few options here, including tangent to profile. And match tangent and match curvature. These 2 are particularly useful when you're trying to match surrounding geometry. I want this curvature of this loft to match perfectly with this face of the handle. That's an example where match curvature comes into play. But again, the idea behind this is blending with surrounding geometry in a more effective way. So this will oftentimes be enough to give you the exact shape that you're looking for. Change the end conditions. Remember, there's a start and end. So you can specify normal to profile for both, for example, and create a shape that's normal to both for a longer period. And you can set a factor. So I can set the magnitude to 2 and exaggerate that effect. But those are end conditions. Now, if end conditions don't give you the exact detail that you're looking for, if you're looking for even more control over the shape of the loft, then you really want to get into what we refer to as guides. And guides are a little bit more detailed. They are actually sketch geometry that's a reference for your loft. So real quickly, we're going to roll up above this loft. If you look closely, you'll see these splines that I have, these spline sketches that are here. And their purpose is just there as guides for our loft. And the idea behind it is I want to control the exact contour from this sketch to the rectangle. And I want the loft to follow these shapes. All right, so let's jump into the loft command. Now the key thing with guides is you select guides from the drop-down, and then you select your guide sketch entities. Okay, and that's really it. The contour of the loft will follow those guides exactly. Okay, so again, if you end conditions are the easiest to apply, and if that gives you the shape that you're looking for, great. If it doesn't give you exactly what you're looking for, guides are the solution. And again, they're going to take a bit more time, but they allow you to control it with a lot more accuracy. Essentially, it's following the exact contours that you've sketched. So that is a guide. One last tip with guides and lofts is a very cool thing in Onshape is if I edit a sketch, there's this button called Final in the sketch dialog. And the neat thing about this is if you turn on Final, I can edit the guide and watch the loft update live. So I don't have to edit the sketch, rebuild, look at the part, see if it looks right, edit the sketch, rebuild, look at the part. I can just turn on Final and tweak the profile to make it match what I'm looking for. So you can update guide sketches live and watch their effect on the loft. And it's a very powerful thing, again, because oftentimes guides are all about getting the transition smooth or the exact contour that you're looking for. So just a tip, the final button while editing a sketch. And this is not specific to lofts or guides. The final button is anywhere after you've created a feature using a sketch. So good question that's popped up. A few questions. Are the parts used during the presentation available to the public? Not all of these parts are public, and there's no specific reason other than no one has requested them, but some of them are, and I would definitely take a look. The cylinder example I'm going to show you in a second is a public model. A question, what planes were your guide curves sketched on? That's a very good question. Let's jump back here. So there were 2 planes that had to be created for those guides. So if you look, I've inserted a plane here, and just real quickly, if I edit this plane, it's essentially just 3 points. 2 points on the rectangle sketch and a point on the circle sketch. And so those 3 points can create a plane, and then I construct my guides on that plane. And there was a plane on each side. So here's the first one, and then there is the second one. Okay. And again, they were just using reference points from the sketches to construct them, and then those planes were used to actually sketch the guides. All right, so that is just some tips again about the loft command. Again, the key thing with the loft command is if you need a very specific shape and you're not easily getting it with an extrude, revolve, or sweep, it's often the tool you resort to. It will take you a bit more time, but you really have the utmost control over the contour and the shape that you're creating. So that is loft. Let's move on. Now, the next example, and this, by the way, is in the public model. So if you do a search at the very top, you should see it. It's called the pneumatic cylinder. This is a part off of that pneumatic cylinder. What I'd like to show with this is the hole feature. And this is just a commonly asked question. Is there a way to automatically add certain size holes to my part? You know, for instance, if I wanted a 1/4-inch counterbore, for example. The key thing there is it's all integrated into the hole feature. Question from earlier. So if 120 degrees changes, the planes change. There was not 120 degrees defining those planes from earlier. Forgive me if I'm confusing this with something else. The planes that I created earlier were referencing 3 points from sketches. So if those points change, yes, this plane would change. But there wasn't a 120 degree value. Forgive me if I'm confusing this with something else. Okay, so back to hole feature. I want to create a counterbore for a 1/4-20 bolt, for example, or I want to create a countersink hole. How do I do that? How do I find the standard hole sizes? And the answer to that is hole feature. And the neat thing about hole feature is it's very forgiving in how you reference points. So the first thing, you select hole feature. You select the type of hole that you want. Counterbore, simple hole, countersink. Define the in condition. Now, it's an important thing to point out, if you are modeling multiple parts together, remember you can model as many parts in a single part studio as you want, you have this blind and last option, which means you can create a hole through 2 or 3 parts with one command, one feature. So that's blind and last, and will allow you to specify the last part and the depth into that last part, and it will automatically cut a hole through a series of parts for you. So that's the depth, and then you specify the standard. ANSI or ISO standard, what size, is it clearance, is it tapped, is it drilled, what size hole do you want, and what's the class fit. But once you've defined those things, it's really just a matter of selecting a point. Now in this case, I want to merge it with the end here. And as soon as I select that, you'll see a counterbore hole has been added. Okay. Now, a few things that I want to point out. In this example, all I did was select a sketch point. So you'll see there's just a simple sketch point there, and it adds a hole normal to the direction of the sketch point. What's really neat about this command is you can select points in any direction using almost any sketch plane, and it will automatically find the part that you're looking for. So here's an example. I have these 2 points that are just floating in space. They were created on this plane here. If I select those points, one of them, let's say, notice that although the point is way up here, the counterbore feature depth is correct. So it recognizes where it intersects the geometry and then starts the feature there as opposed to where your point may be. And the big reason that I bring this up is it means you don't have to be really critical about where you put your points. You can put your points on a plane above the feature and then allow it to find the part and determine the depth from that point. So again, just a key thing to point out, and it works in any direction. So here I have 2 points going down here. If I select another point, because the normal direction of this point is a different direction, there's a hole going the other way. Okay, and notice again that it doesn't really start the counterbore depth until the hole is fully engaged because it's recognizing that the geometry isn't completed. The beginning of the feature doesn't start till here. So the main thing I want to point out is, you don't have to be really critical about what plane your points are on. As long as they're above it, it will automatically detect where the hole should intersect the part. In a lot of other CAD applications, this is a really tedious process where you have to insert all these planes and do all this work to make sure that your point is exactly on the surface. In this case, that's not necessary. Okay. And that is the hole feature. It's real simple. You define the hole type, your standard, the hole size, and then you select points. Okay. I hit the green check OK, and there's the holes. Question, is there a thread feature that works like the hole feature? All that was shown earlier was a manual method using a helix. There is not a thread feature that will cut threads, no. The helix will allow you to cut threads, but you need to create a swept cut to do that. So there is still a step involved. There's not a dedicated thread feature that will automatically thread a hole, no. And again, oftentimes, that level of detail in the 3D model isn't used, and it's simply called out in a 2D drawing. But if you want to go to that level of detail, you could certainly actually add the helix, draw in a triangle, and do a thread cut. Okay, so let's move on. Now, this is the hole feature. Again, just selecting sketch points. So you sketch a series of points, you select those points, and it adds holes wherever those points are. The next command I want to get into is the derived part, or the derived feature. And this is very useful in a number of different examples. The question often came up before, or it has come up and it came up before. How can we link together parts, or even parameters, or sketch entities, or certain values? How can we link these things to each other? And the answer is the derived feature. You can insert derived parts, derived sketches, derived planes, derived helixes, all kinds of different examples. But it allows you to insert a part from another part studio into the current part and use it to drive things. And the neat thing about this is when you change the original, the derived instance will automatically update. So let me walk you through an example. Now, the common example I give for this is, let's say that I've imported 2 parasolids. So here's 2 parasolid tabs that were added to the document. You can see they've been translated. So these are imported models from another CAD system, a top casing and a bottom casing. Okay, so I've imported these parasolids into the document. I need to make a flange that joins these 2 parts. Right now, they're in 2 different tabs. I need to bring them together and then model my part around them. So let's jump into Part Studio 1, which is a blank part. And we're going to use the derived feature to insert the 2 parasolids. Okay, so I select the bottom case. It inserts the bottom case part into my part studio. Right? And then we'll do that one more time. Select the top case and insert the top case into the part studio. So now I've taken the 2 parasolids that were totally separate files generated and sent to me maybe via email. I've imported into the document, brought them together in a single part studio, and now I can start modeling my flange. And I can use the geometry as reference. So now I can use the imported model to attach my sketch geometry. Right? And so it makes it very easy to work around existing models. Now I'm using this example of working around existing models, but this works the same way if you like to use layout sketches, for example. If I like to create a single sketch that drives everything, I create one part with nothing but a sketch, and I use that one sketch to insert into other parts so that I have one master place to control everything. But now I can even do things like convert, the existing edges. So here I'm converting the edges of the imported model. We'll extrude, and we'll extrude this to a depth of 0.5. So now I've imported these two parts into one part studio and modeled my flange with respect to them. Right? So it's a very easy workflow, and one that I want to point out again. Derived feature allows you to insert parts, sketches, planes, helixes from other tabs into the current tab. And the key thing here is they update. So let's test that. Let's make a change. I'm going to go back to the bottom casing, and I want to make a change to this model. In this case, we'll do a move face, offset, select the face, and we'll just do a 3/4 inch offset. Okay. So all I'm really doing is I'm making this outlet diameter smaller. Right? So I'm making that diameter smaller. Let's go to the top casing, do the same thing. Move face, offset, 3/4 inch, and we'll select the face. And so now I've made the outlet diameter smaller on both parts. The key thing here is because our instances were derived, when I go back to Part Studio 1, where I modeled my flange and the inserted parts automatically update. So now you'll notice my flange diameter is much smaller, and of course, if I hide my flange, you'll see the parts that were inserted using the derived feature are also smaller. So the key thing there is they're linked. So if I update one in the one tab, any instance where it's been derived will automatically update. Okay. So that is the derived feature. I like to use the example of imported models, but again, it could be your own models, your own sketches. It really depends. But it is a technique that oftentimes is very common, kind of this master model technique, where one tab, one sketch, one feature, one part may drive everything. And then, you have a whole bunch of things that may be linked to it. So that is the derived feature. You can use it, again, insert parts, sketches, whatever it may be. One of the last examples that I have for you is compare. And compare is definitely one of the more useful commands. Now, as I start to get into more and more features, I start adding more and more things to my model, the question often comes up, is there a way to see the difference between my model today and maybe my model 6 months ago? Or maybe is there a way to see the difference between revision A and revision B? Maybe I have 2 revisions of the product out there. Is there a way to compare? And the answer is absolutely. The first thing I want to point out about this is what we call versions. Versions, think of versions as a snapshot of the entire model, the entire document. So if for instance, I'm designing a product like this link, and I've decided that this is revision A, and I want to go to product with this, I want to be able to go back and look at this state of the model at any point. You'd want to capture that with a version. So that's one of the first tips. You can hit create version, give it a name, and it will automatically add and capture a snapshot of the model. And the neat thing about that is you can go back and look at it. So you can go back at any point and say, okay, let's look at revision A. So that's one of the first tips that I want to point out is we can capture those major milestones. Now that's different than what we call history. So just next to the versions button is manage versions. And if I go into one of the versions, you'll see all the changes that happened to this model. So I can see every single change that's ever happened to this part since the very beginning of the part itself. And the question came up, well, can we go back and compare my model to 6 months ago? You can go back to any moment in the history, and under the gear menu, choose compare. Okay. And by the way, you can also restore back to that point. So you can think of history as an infinite undo. right? You can go back to the moment it was created and restore back to any point, but you can also compare. So now, how do we use compare? As I mentioned before, you can compare moments in history like this, but you can also compare major versions. So let's take a look. This is the main version, and you'll see the design as it sits today. However, if I left click revision A in the list, revision A loads. Now this is a view only snapshot, but again, this was created in August 2015. So this is how the model looked on August 13th, 2015, when this version was created. And you can see that it's a little bit shorter. There's no big boss on the end here. So there are some small changes in the model. So again, you're capturing those versions. What I want to point out, though, is what if I wanted to compare this model to revision A, to the version that was created on this date? Under the gear dropdown, you can choose compare. So under version, in the gear dropdown, you choose compare, and it will take you into the compare mode. Now, there are two things to point out about compare. First, you get a list-based comparison of the differences, and you also get a graphic slider, giving you a graphical or visual representation of the differences. The first, and I think probably the more popular, is the list-based comparison. It allows you to see exactly what's different. Sketch 1 is different between the two. Extrude 1 is not the same. You'll see the not equals. If I left-click the extrude, it tells me exactly what's different. In main, it's 20 millimeters. In revision A, it was 22 millimeters. Okay. I can see if I select the fillet, in main, it was 4 edges, radius 4 millimeters. In revision A, it was 6 edges, radius 5 millimeters. So I'm getting very specific feedback as to the differences. You also get a list of what's in one and not in another. So if I, for instance, create a fillet in revision A that doesn't exist in main, I can see that. If I create a chamfer that exists in main but doesn't exist in revision A, I can see that too. So again, the main thing I'm trying to point out, a very specific list, everything that's different between the two things that you're comparing. Okay. So that's the list-based comparison. You also have the graphic slider. And the graphic slider allows you to just grab and drag and dynamically see the difference between one version and another. Okay. And again, you can do this between two versions like I'm doing here. You can go back to some moment in your history and do this. It's a really valuable tool that, again, very powerful if you just want a breakdown of what's the difference between these versions or these moments in history. Okay. So that is the compare command. Now, a tip about compare: to get out of compare, you want to select the workspace that you want to go back to. In this case, main. So I'll select main as the version I want to go back to, and it takes me back into that main version, so I can continue editing. But that's a big tip. The compare command, again, it's in the gear dropdown. So you'll see that under the gear dropdown for versions or moments in history or even branches. So if you're creating branches, you can compare those two. All right, so that is what I had planned for you today. We have a few minutes left. I'm going to stick around and answer any questions. I see a few questions there, so bear with me. But again, I'm going to stick around and answer any questions. Real quickly, going forward, if you haven't already, we really encourage you to try Onshape in your professional environment and let us know what you think. There's a feedback tool that's built into Onshape. We've tried to make it very easy to give us feedback. So please use it. It's under the help menu. Try it in your professional work and let us know what you think of it. Also, encourage you to invite others and share. I showed you the share dialog. It's in the top right. You just enter their email address to find their permissions and hit share. So it's very easy to do. Definitely encourage you to share and try out some of the real-time collaboration and so on. The last thing I want to mention is if you're interested in meeting local users or maybe interested in establishing your own user group, we'd love to hear from you. We'd love to help you set things up. So I am going to stick around and answer any questions. So bear with me. I see a few there. But that's it, everyone. Thank you and have a good day.